So we are going to get started here in just a moment. So, giving everyone else a little bit longer to show up. So let's hold on for maybe another minute or two, but we will get things started soon. Wait, that looks about like everyone. I'm seeing a lot of familiar names. Actually, I think everyone in this class has taken a class with me before. Is that true? So is anyone here new? Is anyone here not familiar with how I run things? Because if everyone here is familiar with how my the classes go and everything like that, I'm just not gonna spend the time at the start to do that. I guess I can do a quick rundown. So hello again to everyone. It's nice to see you back after the summer. Well, after most of the summer, I guess. Summer's not exactly over yet for the most part. But we are starting here a little bit early. Reason being, we do want to get in 20 weeks, right? So that we have a little bit more time to go over the material. So that's just kind of the idea there. For those of you who took Algebra 1 with me, we did not actually completely finish the Algebra 1 textbook, but that's okay. And the reason why that's okay is because in the Algebra 2 textbook, those final few chapters that were covered in the Algebra 1 textbook, they are also talked about in the Algebra 2 book as well. So it's not a big deal. We will get to cover this exact material that should have been covered then in this book anyways. So don't worry about it. We will eventually see it in this book. Yeah, so just as a quick reminder for for everyone, just I guess it has been a while. So again, my name is Kitong. I'll be teaching this class for you guys. You guys can call me by first name or just Teacher Liu, anything like that's fine. I don't really mind too much. It's not a big deal for me. So when we do go through this material, right? Same as always. I am good with keeping cameras off, reason being, once I start sharing screen, I want you guys to be paying attention to my screen, right? So keep the cameras off. It also means that you guys get to view the whole screen with just the shared screen, right? Rather than having to use part of the screen for any video feed, right? So that's what I would prefer. And as we go through the questions, when I call on people to work out problems, please, let them work it out, right? I understand sometimes, they might take a little while to answer the question. Sometimes they'll struggle a little bit, right? But, if someone else struggles, it's very possible that, at some point, right, everyone comes across a hard problem, right? So in that situation, I'll take care of it, right? Don't worry about it. If I feel like it's taking a while, if I feel like we should get moving along, I will help them out, right? But if you guys want to help out, right, just raise your hand, and then if they're struggling and I see that, I'll ask for help that way. But don't just unmute and directly answer. I guess apart from that, one other thing is if you guys do have questions, please make sure to let me know. Either when I ask or just raise your hand. If you guys aren't familiar with how to do that, if you mouse over the screen with all the names, right? If you mouse over, there's a button that says reactions, and then under there should be a button that says raise hand. What that will do is it will bring your name to the top of the participant list, and then I'll be able to see it. I'll be able to see, okay, well, this person has something they want to say. It's either a question or something along those lines, right? If you have a question, please do let me know. If you have a comment or something to add on, just writing it in the chat is good. I don't want you guys to, all to be jumping in, right? If that happens, then we'll spend a lot of time just like listening to what everyone has to say, right? So if you guys, have something to add on, right, please drop it in the chat. If I think it's, if I think it's really important, I will, read it out loud as well. If you have a question and you're afraid you're going to forget, right, feel free to write it out in the chat as well. If you do that, right, it will be there. I'll be able to see it. I'll be able to, read it out loud. Okay, and answer it directly. If you don't want everyone to see your question, what you could do is you could message just me, right? Instead of saying to everyone, you can send that to just me. I'll be the person with the parentheses host in my name. So if you want, you can, send it to just me, and then I'll have to read out your question, but I won't have to, I won't say who it came from. And then one other thing is, if you guys, if you guys don't want to answer any questions, just, write it out. Just like, let me know that you don't want to answer any questions. I won't ask you any questions for that day. For any reason, right? Like if it's either, your mic doesn't work or you're outside or anything, right? It doesn't matter. Just let me know and I won't call on you. And then lastly, if you guys are late, if you guys have to step away, anything like that, just let me know that you'll be gone for a moment, or that, like, oh, I'll be back in like 5 minutes or something like that. Just let me know something like that. And then I won't call on you during that time, right? I don't want to, like, I just don't like it when I call on people and then I just like don't get any answer. It should, it just takes a little bit of time, right? Yeah, so those are the main things that I really wanted to cover. And something else I wanted to say is, for this specific class, we run into a lot of problems with the textbook. And what I mean by that is the Art of Problem Solving book for the intermediate algebra class is a lot more advanced than high school tends to get. And I will make a note of that when we get to the points. So what I mean by that is, say, for example, when we go into things like chapter 12, right? Things like the Cauchy-Schwarz inequality. That's something that you will never ever have to learn in high school. That is something that you don't even really learn until college. I did not learn about Cauchy-Schwarz until I was in year 3 of college. So what does that mean? What that means is, when we walk around and get to these more difficult topics in this book, we are going to do a lot of skipping. Especially for things like 10.6, right? Even for 10.6, right? Like nested sums, right? That's something that you're never going to work with in Algebra 2. Things like, just even all the way down here, right? Things like in chapter 19, chapter 20, right? Things like that. Chapter 18, mean inequality chain. That's something, again, right? You don't really learn about that in high school. So what we're going to do for this class is we are going to keep it at a high school level. There's a lot of questions even within the certain chapters, right? There are some certain like entire sections that are just way too difficult for a high school level. But even within the section, sometimes there's one or two questions that are much, much more advanced than what you would see in a high school Algebra 2 level class. So what we're going to do in this class is we're going to remember that our focus is for high school, right? None of you guys are in college yet, I would hope. None of you guys are in college yet. So we're going to keep this at high school level. And with that idea in mind, that means that, whenever we hit upon something that's a little bit harder than a high school level, we're going to skip over it. Or maybe not necessarily directly skip over it, but maybe I'll just, spend a little bit of time kind of explaining the general idea from this question, or kind of like, or at least, right, at the very, very, very most, I will work through the question. I will not make one of you guys work through the question. There's also a lot of questions in this book that are very theoretical in nature. And at the end of the day, when you work through questions like, when you work through Algebra 2, you're not going to be asked about theory questions when you are actually working, through the class yourself. you're going to be asked to apply it, right? So I think a lot of the theory questions I will work out when it comes down to it, especially the harder ones. But when it comes to the application questions, applying the theory that we just learned, that's going to be all you guys, right? So if this is your first time taking a class with me, I make you guys work out the questions. If this is not your first time working with me, you'll know how it feels. All right, so with all of that being said, any questions before we get things started in this class? Going once, going twice. All right. And as always, if you guys are taking a little bit of time to type or anything, that it's fine, right? I'll see your question eventually, and then like once I do see it, I'll make sure to answer it. All right. So where do we start? Algebra 2, right? So the idea behind Algebra 2 is that algebra as a whole topic is very in-depth. There's a lot that goes into algebra. And the reason why we have to go through Algebra 1 and Algebra 2 is that, there's so much material that we cannot cover it in a single book. We cannot cover it in a single year. So what we do, we split it up. We split it up into multiple different years. In fact, we actually split it up into probably at least like three or four different like full-on years. But in the course of high school, you're only going to go through the first or second, first and second year for the most part. Usually you're required to take up to Algebra 2. And okay, I don't think I said this, but if you guys are late, if you guys have to leave early, anything along those lines, don't worry. We do record every single class that gets put up onto a Padlet. And then from that Padlet, you can just watch the recording. That recording stays up for 1 week after it's posted. So please make sure, watch that during that 1 week, all right? Okay, so Algebra 2, where was I? So we are going to be, going through quite a lot of material, but what we're going to find is that a lot of this material builds upon the material that you learned about in Algebra 1. In fact, we are actually starting a lot later than what the Algebra 1 book starts off at. The Algebra 1 book starts off with arithmetic. It actually starts off with the rules behind addition, multiplication, division, and subtraction. We aren't starting that early. One of the later, if you remember from Algebra 1, one of the later chapters in the beginning portion talked about how to solve equations. What I mean by that is how to solve equations with variables. And that is where we're going to start off in Algebra 2. So let's take a look with all of this here. So let's start off with problems 1.1 through 1.4. So the ideas here is we're trying to solve for the value of the variable. And there's one thing in mind. There's one thing that we want to do every single time. We want to get the variable alone. This is called isolation, right? So the question about, behind all of this material here, how do we isolate the variable? What are the different things that we can do? Let's take a look at these problems. So let's just start off. Let's start off at the bottom, actually. So I feel like I've started off either at this top or in the middle for every single one of my classes. Let's start from the bottom. So Yuhang, problem number 1.1. Let's start with that. Yuhang, you there? Going once, twice. Okay, how about Sophia then?
Is it 1.1a?
Yeah, you're gonna actually do both parts here. They're both pretty quick, hopefully.
Okay. So for the first one, you want to isolate R. So you can move the 7 from, or you can move the 7 from the right side to the left side.
Okay.
And also move the 3. And then
yeah, so before you do any moving, actually, because you do have this 7 and 3 like that, what you can do is something called combining like terms, right? So combining anything that looks the same, right? So this 3R and 2R can be combined, the 7 and 3 can be combined, just to mean that you can do things in a couple fewer steps rather than subtracting 7, subtracting 3 2 separate times. Do you kind of see what I mean?
Yeah.
So this would be 5R minus 2 is equal to 10 minus R, right? And now instead of moving over the 7 and the 3 separately, you can move them over together as a 10 instead. Okay. So what does this give us here?
I guess you move the 10 to the other side and you move the 5R to the other side.
Yeah.
And I think you get -12 is equal to -6R.
Yeah.
And that means R is equal to 2.
Yep. All you do is at this point you divide by -6 and you get R is equal to +2. I do agree with you here. And remember, right, the idea behind moving over to the other side, what you're really doing is you are you're just subtracting 10 from both sides, right? Remember, the idea is you can add, subtract, multiply, divide onto either side, as long as you do the same thing to the other side as well, right? So we subtracted 10 from both sides, we subtracted 5R from both sides, and then we divided both sides by -6. And that is how we got our answer. Nice work. What about part B?
For part B, I think I would first get rid of the fraction because I don't like working with fractions.
Yeah, that sounds fair.
So
how do you get rid of that
you
fraction?
multiply both sides by 3.
Yep. So that gives us
2t plus 21 is equal to 9t minus I think that's 81.
Yep. What you've also done here is you've also went ahead and distributed this as well, right? So I do agree with you here. That is what we get here. All right, what next?
And then you move the 81 to the left side and the 2t to the right side. And you get I think it's 102 is equal to 7t.
Yeah, and then you divide both sides by 7, right? So you get t equals 102 over 7. You can't actually simplify this anymore. But yeah, so that's exactly it here. Any questions over these two problems here? So we are actually allowed to also make any steps that we like, given just to make things a little bit nicer for us, right? So in this case, we multiplied both sides by 3, even though we didn't really have to, just to make the numbers a little bit nicer to work with. And that's something that we are 100% allowed to do. All right. If there are no questions, then let's take a look at 1.2. Minmin, let's have you do parts A and B, and then we'll have someone else do part C here.
Yeah, so for for A, it would be you can first subtract 2 from you can basically like subtract 2. And then
so subtracting 2, you mean from both sides, right? So we get rid of that. We get -4x is greater than or equal to +8. Does that look good to you?
Yeah.
Mm-hmm.
And then you divide by -4.
So what happens when you do divide by -4? What do you need to do?
The sign is switched.
Yeah, so when you do divide by a negative number, you need to make sure, right? You need to make sure that you do flip the sign, right? So this becomes x is less than or equal to -2 now. Does that look good to you?
Yeah.
Mm-hmm. And is that our final answer?
I think so.
Yeah, that's it. That's exactly it. We're done, right? We've gotten x alone on one end, right? So that's exactly what we're looking for. So x is less than or equal to -2 is our answer to part A. What about part B?
Yeah. So for that, you can subtract 5 from both sides. So you can get 2 minus 3t, that sign.
Less than?
Yeah, less than 2t. And then you can do like plus 3t to both sides. And then so it would be 2 is less than 1t.
So just t alone, right?
Yeah.
So when we say 2 is less than t, how do we make this, t is blank something? You know what I mean? Like, how do we put t on the left side, basically?
I think you do like t and then you switch the sign and then 2.
So all you have to do is just, think of it as if you just put it through a mirror, right? Okay, it just completely flips over. T is now greater than 2, and that's our answer to part B. Yep. Any questions over part B here, or part A and part B here, right? So we've seen, right, when you divide by a negative number, even if you multiply by a negative number, you do need to make sure to flip that sign. And then when you do, want to move things from the left and right sides, right, you also need to flip over that sign, right? So those are the two situations where you'd have to do that. All right. Max, how about part C here? What should we do here?
Part C.
Mhm.
I'm thinking.
So what's the difficulty with this one?
I don't know what to do first.
Yeah, it seems a little bit difficult to know where to start, right? And so what's the difference between what you see in parts A and B and what you see in part C here?
Yeah.
There's a pretty obvious difference, right? But what is that specific difference?
Can't find it.
Well, the difference is that, in parts A and B, we are comparing two separate things, right? But when we're
There's
comparing,
three separate things.
yeah, there's three things that are being compared. You're told that this has to be less than this, which is less than or equal to that. The problem here is what this means is you actually have two inequalities that must be true at the same time. This guy needs to be less than this, and this guy needs to be less than that. So what does that mean? What this means is instead of looking at it as one thing, right? What we can do is we can actually look at it as two separate inequalities. And the reason why we want to look at two separate inequalities is because if we try to solve it as one inequality, it's very, very difficult to do. And the reason why is because we have a 3x here, a 4x here, and a 1x here, which means that the x's, no matter how you add or subtract them, are not going to all cancel. There's no way for me to only get x's in the middle. I'm going to have x's in two of these at the same time, no matter what, which is not what we're looking for. Does that make sense?
Yeah.
So the way to solve this is to actually break this up into two separate inequalities. We have to solve first 3 minus 3x is less than 4x plus 7. And then we solve 4x plus 7 is less than or equal to 8 minus x. Does that make sense?
Yes.
Okay. Well, how do we do this? We've seen how to do this already, right? We've seen how to do this in parts A and B. So let's just do it one more time. So what do we do here?
So 3 minus 3x is smaller than 4x.
Yeah, so how do you solve that first inequality here? What do we need to do? So remember, your goal here is to get x alone, right? So to get x alone, you need to move all your x's to one side, move everything else to another side. So what we want to do here is, it's easier, I find it easier to add x's than to subtract. I find it easier to work with positives than negatives, right? So the way that I would answer this is I would say, okay, let's add 3x to both sides, right? So that gives me 3 is less than 7x plus 7. And then from here, right, we only have x's on the right side. So let's move all the numbers to the left side, right? So the 7 goes over to the left, which brings us to negative 4 is less than 7x, or negative 4 over 7 is less than x. Does that make sense for the first one?
Yes.
Any questions about how I got that?
No.
Okay. So can you do this second one then? So I've done the first one for you. How do you do the second one?
So 4x plus 7 smaller than 8.
So I know you're saying like smaller or bigger than, right? And that is true, but the mathematical term for this, the way the name of this sign is less than or equal to. So try to use that if you do remember, all right? Okay. So what can we do for this one? What's the first thing we need to do? What's the goal that we're going for?
The goal is to get if it's
Yeah, so the goal is to get x alone, right? We want to get x alone on one end. So what's the first thing that we should do to take a step towards that goal? What's the first thing we did in these steps here? What's the very first step we took, Max?
don't know.
The very first step we took was we added 3x to both sides. It's the first line I wrote down, right? So that was the first step that we took. We added 3x to both sides. Now, are we going to add 3x to both sides here? No, of course not. Why did we add 3x to both sides, right? So the question here is you need to understand why we took every single step. So the first question is, well, why did we even add 3x to both sides? There's a very good reason for it. Because we have a negative 3x right here. So in order to get rid of the negative 3x, in order to cancel it out, we add 3x to both sides so it goes away from the left side. So we do not have that 3x anymore on the left side.
Okay.
Does that make sense?
Okay.
Okay. So in this second example here, there's two options here. We have a 4x on the left side or a negative x on the right side. Which one do you want to get rid of?
Can I get rid of x and make it
I can't hear you. You need to speak up a little bit.
5x plus 7? This is less than or equal to 8?
Yeah. All you've done here is you've added x to both sides, right? And the reason behind that is, if we add x to both sides, we get rid of the negative x. So that's our first step here. An alternative first step would have been to say 7 is less than or equal to 8 minus 5x. But again, right, it doesn't matter. You just get rid of x from one of the two sides, either the left or the right. It's your choice. You've picked to get rid of it from the right side. Okay, what else do you have?
Now can I minus 7 from the left?
Yeah, why can't you, right? Of course you can. So you get 5x is less than or equal to 8 minus 7, which is 1. And what now?
And so -4.
Whoa, hold on. You're subtracting 5 from both sides, right?
Yeah.
Let me ask you, do you have anything that's being added here?
No.
Did we subtract 7 from both sides here? What did we do here to get to our answer here? We divided. Remember, the opposites of addition is subtraction. The opposite of subtraction is addition. But the opposites of multiplication is division. So when you're trying to get rid of something that's being multiplied, you need to make sure that you divide. Now you might ask, well, back here then, why did we subtract 4x from both sides? Well, remember, that's because the whole entire 4x, or why do we add on 3x to both sides? That's because the entire 3x is being subtracted. So if we add on the entire 3x, that's okay, right? But here we cannot subtract 5 because we do not have 5 as an individual number being added on. So this 5 needs to be divided. So if we divide by 5, we get x is less than or equal to 1 over 5. Does that look good to you?
Okay.
And that gives us our final answer of -4 over 7 is less than x, which is less than or equal to 1 over 5. And that is our inequality.
Okay.
So would definitely recommend, getting a little bit more familiarity with solving an equation like this, whether it's an equation or an inequality, but just, getting a little bit more familiar with how to solve this step by step, right? Remember, just always ask yourself the same exact questions. Number one, what am I looking for? What I'm looking for is x to be alone in one end. Number two, how do I do that? Well, first off, I choose one end to get rid of x's. Either get rid of them on the left side or get rid of them on the right side, right? And then whichever one you've chosen to get rid of them from, right? If they are now all on the right side, on the left side in this case, get rid of everything else on the left side. Move everything else over to the right side. That's the idea here. Now, once we've reached this point, we can actually write this answer in what's called interval notation. Interval notation, if you guys have, took Algebra 1 with me, you guys should remember this. But if you didn't, this is, quick idea of what this is. So if you have a less than symbol, what this means is it's a parenthesis. If it is less than or equal to or greater than or equal to, so anything like that, it's going to be a bracket. So what this means is you're going to write a sort of, an interval from a smaller amount to a larger amount. So the smallest amount that you could be, in this case, that's going to be the -4/7, right? That's the starting number. And since we are not allowed to equal -4/7, we're going to use the parenthesis here. Then it's a comma. And then over here, the largest number we're allowed to be is 1/5. And since we are allowed to actually be that number, we're going to include it with a bracket here. So this is our interval notation. We use parentheses to represent less than, greater than. We use a bracket to represent less than or equal to or greater than or equal to. Now, this parenthesis is also called a strict inequality. And the bracket is called a non-strict inequality. And the idea is simply just, can I equal the number or can I not equal the number? That's it. Any questions over 1.2 part C?
No.
Any questions from anyone else either? One more thing is for those earlier questions that we had, right? So for some of the earlier questions, we had a one-sided limit, one-sided, sorry, not one-sided limit. We had a one-sided interval, right? What that means is it was only something like, simply just x is less than 2, right? To write this as an interval, what you would do is you'd say, okay, well, what's the smaller bound, right? What's the lower number that I can be? Well, I can go all the way to -infinity, right? So that's going to be -infinity. You cannot actually ever reach the number infinity. So anytime you see the number infinity, you're gonna use a parenthesis, and then you're gonna say 2 over here. If you want to say all real numbers, so all numbers that exist on a number line, you just say negative infinity to positive infinity. Personally, I'm pretty bad at writing this symbol. I don't know why. It's just been something that I've always been really bad at drawing. So don't worry if you guys aren't great at it either. All right, enough about that. Let's take a look at 1.3. Luke, 1.3. All right, no, Luke, how about Joseph then? All right.
So I guess I would start with subtracting x squared from each side.
Sorry, one thing before you always start a question, please do read the problem.
Okay, sorry.
You're good.
2x squared plus 5 equals x squared plus 18.
So what you said was the first thing you want to do is subtract x squared from both sides. Why is that the first step you want to do? Can you kind of just explain it?
Because you can eliminate the x squared on one side, so just be x squared plus 5 equals 18.
Yeah, that's exactly it, right? So the idea is we'll get rid of it from the right side. Now we have x's only on the left, and that's exactly, that's the first step towards what we wanted to get to, right?
Yes.
Okay, what next should we do?
And then I think, yeah, you subtract 5 from both sides, so it's going to be x squared equals 13.
Yeah, if you subtract 5 from both sides, that gets rid of the numbers on the left side, which means that we only have numbers on the right now, right? We have x's on the left, numbers on the right. And what's the last thing we need to do here to solve?
You'd have to get the square root of 13, and then it would be positive and negative.
So why do we actually end up getting, so what you're saying is square root both sides, right? why do we actually end up getting plus minus 13? Why is x equal to positive, sorry, not plus minus 13, plus minus root 13? Why is it actually both?
Because square root -2 times, let's say for like 4, -2 times -2 is still 4. So it kind of goes both ways.
Yeah, it's because you don't know what number x is. You don't know if x is positive or negative. And when you square a negative number, it ends up being positive as well. So the big idea here is actually the following. Anytime that you take the square root of both sides and something was squared, right? So if I had something along the lines of, x squared equals whatever, right? If I take the square root of both sides, I have to introduce plus minus. In fact, if I take the square root of both sides ever, I should introduce plus minus, because usually the reason why you would, square root both sides is because you had something that was squared already and you're canceling that out, right? So if you ever take the square root of both sides, you should very, very, very much think, do I need to add on a plus minus? That's what we're looking at here. So the answer here, you actually have 2 answers for x, right? Not just one. Now, Joseph, let me ask you, just considering that we're on this train of thought already, if we square both sides, do we need to think about plus minus answers?
No, I don't think, because it still ends up being a positive.
No, that's actually mostly the correct answer. We don't need to introduce plus minus. However, what we actually do need to do is we actually need to double check that our answers are correct. For example, if I said, I don't know, like if I gave you like, x plus 2 is equal to the square root of 25, for example, and you squared both sides, and I got, okay, well, this, well, 25 is a little bit of an easier number for sure, right? But because it's just, 5, the square root of 25 is just 5, right? You would know x is equal to 3. But if I squared both sides and I said, okay, x plus 2 squared is equal to 25, now all of a sudden I get actually 2 answers. X could equal 3 or -7. And this is, this is a key example of, when it's important, double check your answers, right? Make sure that what you're looking for is actually, an answer that would have worked originally, right? So when you square both sides, what you need to do is you need to double check that your answers do work in the original problem, right? So that is what we need to do there. So things you need to check both if you square and if you square root. So if you square, check plus minus. If you square root, check to make sure your answers actually do work in the original question. Okay, let's look at 1.4. Thanks, Joseph. Actually, before we do that, any questions over that idea behind square rooting and squaring? Okay. Let's look at 1.4. 1.4 actually goes into the exact problem that I just described. Jessica, let's hear from you.
So it's 1 over the square of z minus 3 minus 1 plus 3 equals 3 over the square of z minus 3 minus 1.
Yeah, so how should we solve for this?
We can like first multiply the square root of z minus 3 minus 1 to both sides.
Okay, I see what you're suggesting here. That would get rid of our fraction, right? And that would, that would make life a lot easier. However, there's actually something that I would suggest before doing that, specifically because of what we have in this question. What do you notice about the denominators in both problems? In both sides, sorry, not both problems.
They both have a square root.
How about they're both the exact same denominator?
Okay.
Right? If they're the same denominator, that means that adding and subtracting the fractions is actually really easy, right? Like think about 1/2, think about 1/4 plus 1/4, that's just 2 over 4, right? Or 2/3 minus 1/3, that's just 1 over 3, right? You just add or subtract the numerator, right?
Yeah.
So if I just subtract 1 over whatever that denominator is, I can do that pretty easily, right?
Yeah.
Would you agree?
So,
Yeah, so that would be 2 equals 3 over root z minus 3 minus 1 minus 1 over root z minus 3 minus 1, right? And that's
Yeah.
just equal to
be 2 over.
Do you see how much easier that is?
Yeah.
Okay. Now let's do what you suggested. So at this point, now if we multiply by the denominator, we're able to cancel out that fraction, right? So I do agree with you that that is a much better step at this point. However, what else can we do once we've done that? You'll notice that,
Oh, they're both 2. That's
so you can divide by 2 on both sides, right?
yeah.
Yeah. So this actually gives us 1 is equal to 1 over that, which tells us the square root of z minus 3 minus 1 is equal to 1. Does that look good to you?
Wait,
Can I what?
can you explain it again?
Yeah. So the first step, right? The first step was we subtracted this from both sides, right? So this got subtracted here. We ended up with 2 is equal to 2 here, right?
Yeah.
Okay. Then what we did was we said, okay, well, if I just divide both sides by 2, right? So if I divide this by 2, divide this by 2, I get 1 is equal to 1 over root z minus 3 minus 1, right? Because if I divide a fraction, all I'm doing is dividing the numerator of that fraction, right? Like if I do, if I do 6 over 11 divided by 3, that's the same thing as 2 over 11, right? All I do is divide the numerator.
Yeah.
Right. As for the left side, right, 2 divided by 2 is 1. So that's what we have here. Does that make sense?
Yes.
Okay. And then I multiplied both sides by root z minus 3 minus 1, multiply both sides by that. 1 times that is obviously that, right? And then the denominator here cancels out with that. So I get root z minus 3 minus 1 is equal to 1. Does that look good to you now?
Yeah, I get it now.
All right. Now what do we do?
And then we have to like get rid. We have to move the 1, so it equals to the square root of z minus 3 equals 2.
Yep.
And then we have to get rid of the square root, so we square both sides, which equals to z minus 3 equals 4.
Okay.
And then we add the -3, so it's plus 3, and equals z equals 7.
Yeah. So at the very end here, we actually only end up getting one answer. So this actually, we don't need to test. We don't need to test if it is, if both answers work or anything like that. In this case, we should still test it just to double check. Does this actually work out? 1 over square root of 4 minus 1. So that's 1 over 1, right? 1 over 2 minus 1 is 1 over 1. Plus 2 is equal to 3 over 2 minus 1, which is 1. So it's 3 equals 3. And that is actually true. So we are good here. Z is equal to 7. But yeah, so over the course of this question, right, what we did is, first off, recognizing that this denominator is the same means that we can save a pretty nice step, right? And that was, that was what we did here. One other thing you could have done, so personally, something that I really like to do is if I see something repeated multiple times, so in this case, the square root of z minus 3 minus 1, if I see something like that repeated multiple times, I'll just say, okay, this is equal to y. And then I'll rewrite the equation in terms of y. So I'll get 1 over y plus 2 is equal to 3 over y. That makes things a lot nicer for us, which then tells us 2 is equal to 2 over y. Okay, well, y is equal to 2. Well, sorry, y is equal to 1, right? At this point. Like once you get to this point, y is equal to 1. So that tells us back here, square root of z minus 3 minus 1 is equal to 1. I don't know why I wrote that minus 1 under there, but that's what we have here, right? So that's another way that you could have solved this, just by, recognizing, hey, if I see something that's repeated a bunch of times, just replace it and go from there. That's what we saw here. Any questions here? Sorry, Jessica, I saw that you were about to say something. Did you have a question?
No, I don't.
Okay. Any questions from anyone else? Okay. So with that actually moves us into the final question for this section. That's going to be problem 1.5. Problem number 1.5. There's a lot of parts to this, but these parts actually just bring us closer to the answer, kind of step by step, right? So that's what we're looking at here. All right, Jason, can you lead us through this one? Jason? Okay, how about James then? No James either? Gordon? Remember, start by reading the question. Just read through and then read through part A for now.
Solve the equation for x in terms of c.
Oh, sorry, I meant like from the top until part A.
Oh, okay, my bad.
You're good.
In this problem, we find all values of c such that the equation 3/2 minus 1x equals c. I don't really know where to start here.
Yeah, and that's perfectly fine, right? So that's what the parts of this question really help us out with, right? So if you're ever stuck with a question like this, the nice thing about this book is the different pieces of the problem, right? So part A through D, they kind of tell you in a little bit, not exactly a direct way, they kind of tell you how to approach the question. So part A here says to solve the equation for x in terms of c. Do you know what that means?
I don't really understand it.
Yeah, so that's perfectly fine, right? So do you know what it would mean if it just said solve the equation for x and nothing else?
You just find what x is.
Yeah, just find what x is equal to, right? Put x alone on one end, put everything else on the other end. Well, the problem in this question, the problem in this equation is you cannot actually find the exact value of x. Do you know why?
Because you don't know the answer or like the
well, you don't know the value of c, right? You don't know the exact, you don't know the end value that this whole thing should be equal to. So what you need to do is what's called solving in terms of another variable, right? If I'm able to tell you, hey, x is always equal to 2 times y, that is x solved in terms of y, because it's always 2 times the value of whatever y is. Does that make sense?
Yeah.
So that is an example of solving in terms of y. You put x alone on one end, put y's on the other. That's it. So what we're saying here is put x alone on one end, put everything else, including c, on the other. That's what this part means. Does that make sense?
Yeah, better.
So the goal is I want x alone. Now the question is how? How do I get x alone?
Hold on, I'm thinking.
So what's the first thing that you should do? As soon as you see this question here, basically, what's the first thing, very first thing it's screaming at you to do?
Probably to take away 2.
You can't do that. It's on the denominator of a fraction. So you cannot take away that 2 separately, right? If it was, added on like here, yeah, you could do that, right? But right now it's on the denominator, which means that you cannot work with that easily. You cannot split up a denominator that easily. You cannot do that. Instead, anytime you see a fraction like this, anytime you see a fraction that has a really bad denominator to work with, something that you can try doing is either A, simplify the denominator, or B, multiply it through so you don't have any fractions at all. In this case, we don't have that many terms. The only time when you don't really want to multiply by a fraction, by a denominator, is when you have like c plus a plus, like if you have a bunch of things added together. That makes things a lot more difficult. But in this case, we don't have that. We just have a single thing. So if we multiply through, we get 3 is equal to c times 2 minus 1 over x. Does that make sense?
Yeah, I think so.
It gets rid of the fraction here. And now what do we do on the right side?
We just do the we do like 2c, and then we do like minus
C over X, right?
yeah.
That's called distribution. So at this point, now this is what we have. Remember, what was the goal of what we wanted to do?
Isolate X in terms
Get
of
X
C.
alone on one end, put
Yeah.
everything else on the other, right? So that means that the 2c goes here. 3
Wait,
minus
is that C over X?
yeah, sorry, that's C over
Okay.
X. So 3 minus 2c is equal to negative C over X. Does that look good to you?
Yeah.
What now? So
I
there's a
guess we
problem
just
with this, right?
yeah.
Sorry, you were saying something?
Oh yeah, I think do we just add 2c on both sides?
You just moved the 2c over to the left side. Why would you add it
okay.
back to the right? Right? You just moved it from the right to the left. If you add 2c, you move it back to the right. That's not what you want. You want you want everything on one end and X alone on the other, right?
Oh yeah,
If you
sorry, I got confused.
back, yeah, it's not what you want. You're just taking a step backwards. Instead, what you want at this point is you want to get rid of this C, right? That C, this negative sign even, that's not what you want, right?
Mm-hmm.
So how do you get rid of the negative sign? How do you get rid of the C?
Well, I mean, I don't know. Yeah.
Well, A over B is the same thing as A times 1 over B. So if it's being multiplied, I just divide by it to get rid of it. So this becomes 3 minus 2c over negative c is equal to 1 over x. I just divided both sides by negative c. Does that make
Okay.
sense?
Yeah.
Okay. At this point, if I really wanted to, I could multiply the top and bottom by negative 1 to get negative 3 plus 2c over c is equal to 1 over x. But this is, at this point, this is what we have. Any questions about how we reached this point here?
No, I think I'm good.
What do we do now? Remember, our goal is to get x alone on one end. This is 1 over x. That's not what we're looking for. So how do we get x alone?
Wait, what was the example that you showed me like before about like
I said something like, x equals 2y or something like that, right? The idea is you want x alone on one end, but we have 1 over x here. So how do we get it to become x? What do we need to do?
Do we just multiply the 1 by x?
You could, but then if you multiply both sides by x, now you have x on the right side. On the left side, which is not exactly what you're looking for. The solution is actually a lot easier. You just take the reciprocal of both ends. If I told you 1 over x is equal to 1 over 4, you'd be able to tell me is x equal to 4, right? You're like really quickly.
Mm-hmm.
It's the same thing. All you did here is you just flip the top and bottom, Do the exact same thing here. X is equal to c over 2c minus 3.
Oh, okay.
Does that make sense?
Yeah.
It's the same exact idea as what you did here. So you can do the same thing here, right? If it works on a simpler question, it's probably something that you can do on a more difficult one, right? It looks a lot more, the step here looks a lot more difficult than it actually is. Because all you're doing is you're just flipping the top and the bottom. That's all you're doing here. So that's what we have here. Now the question is, for what value of c is there no solution for x? That's a different question entirely, right? So now that we've gone, from here to here, now the question is, for what value of c is there no value of x? And for that, let's actually turn to Daniel. Daniel, so what value of c is there such that there's no value of x possible?
0.
So what you're saying is if I plug in 0, I'm not going to get a value of x. Is that right?
Oh wait, no, my bad.
You're thinking along the right lines though. Why is 0 the number that comes to your mind?
That was the first number that I thought of.
Yeah, but the question is why? And to think of 0 first, that's actually the right thing to do. But there's a specific reason why 0 is the number you should think of.
If you divide any number by 0, it becomes undefined.
Yeah, exactly, right? So in order to make x not work, I need to divide by 0, essentially, right? So if I do, x is equal to something divided by 0, I'm going to run into problems. That's the idea here, right? So for what value of c is x going to be dividing by 0? In other words, if I were to say x is equal to, something divided by 0, how do I get this 0 on the denominator? What value of c gives me that? That's just 2c minus 3 equals 0, is it not?
Yeah.
Because if 2c minus 3 is equal to 0, then that means x is being equal to something divided by 0. So what is that value of c?
3/2.
That's it. So the only value of c that makes this not work, c equals 3/2. Any questions here? So yeah, that's exactly it here, right? So that's what we have here. So the value of c, which has no equation, no equal value of x, right? No solution for x, is 3/2. Everything else you can plug in, right? You can plug in c into the numerator, into the denominator, find the exact number that x should be equal to. You'll get something every single time. But only for 3/2 do you get something that doesn't work. All right. Any questions over 1.5 here? So one of the questions that you might have is, why did we do the first thing? Why did we solve for x in terms of c? This is the first thing that might be a little bit tricky to do. The reason why we solve for x in terms of c is because we are looking for something. We're looking for something that has no solutions for x. What that means is we want x to be equal to something, right? We're trying to find a value of x given a value of c. That means that we're setting up x in terms of c, right? So that's why we do that in the first place. That's why we wanted to create this equation in the first place. It's because of what we were asked. We're looking for a solution for x given a value of c, right? Solution for x, value of x, given a value of c, that is solving for x in terms of c. That's exactly, basically just word for word what we're doing. So with that is all the problems in section 1.1. So this idea here, all of these ideas, this is stuff that we covered in Algebra 1. So if you want to review this in the Algebra 1 book, the Algebra 1 book does go more in depth than just this. This is like a quick, this is really just a review in here. So so to kind of talk through this, this is actually both chapter 3 as well as what we're kind of getting into is we're getting into chapter 5 material in chapter 1 here. So what I mean by that is, like, from the Algebra 1 book, this is chapter 3. And what we're going to go over in sections 1.2, 1.3, 1.4, for the next couple of sections, that's going to be chapter 5 material. So we're going to see all of that as we move on through this chapter. But with that, homework for this week is going to be just section 1.1 exercises. And if you guys found this quite challenging, right, it's probably just means you just need to review Algebra 1. If you haven't taken Algebra 1 before, I would highly recommend taking that class before this, because as you can see, right, all the things covered in Algebra 1 are coming back here in Algebra 2. But with that, that's going to be it here for this week. If you guys have any questions, feel free to stick around. Otherwise, that's going to be all here for today, and I'll see you all next week.
Thank you.
You.
Thank you.
Bye.
Bye, bye.
Bye.
Hello, Helen, can you hear me? Hello. Well, if you can, I don't know, but we actually just finished class. So this class is actually the hour before this, so you missed out on the whole thing. If you do want to, review it, just go ahead and watch the replay. That will be posted up on Padlet. Yeah. All right. Bye-bye.